Good morning, students. Today we are going to talk about a spatial design of another antenna using CST, that is horn antenna. Horn antenna is a microwave antenna, and for this antenna, let me share my screen. This antenna is a 3D pattern, as our title is designing of a pyramidal horn antenna. So it is one of the aperture type of antenna where the front structure is fundamentally, this front structure used to be like this. Like if you say, it may be rectangular or square pattern here, and this pattern is connected to the waveguide. So you can say there is a flaring angle exists between them. So it is a waveguide, and waveguide is going to be attached with all four parts of this. So you can see there's a flaring increase of this, and this area is a aperture of this. In this direction, we have E field, so we call it as the length, or we can say theta E, and this angle is theta H, the field of in the H direction. To create this structure, let me open a quick tutorial for designing this structure. Open your CST Studio Suite. So in a student version, we are going to create one modeling of this horn antenna. So start with this. It is a gigahertz. It works in the microwave frequency range. So gigahertz. So select antennas. Go to waveguide horn antennas. Time domain. And here this should be default because the dimensions which we are going to take is in the same direction dimension of millimeter, and the frequency gigahertz. Other all parameters, time, temperature are all the SI units as default available. So don't change anything here. Frequency, you can, we are going to design it for a frequency of 4 to 7. We are going to monitor this. 4 gigahertz is the range, and 4 to 7 is the range of frequency in which we are going to represent it. E field, H field, far field, and power flow monitor, because power also in the surface current we want to check in the antenna. So 4 to 7. Name your project. Say horn antenna, waveguide horn antenna. With your register number, you can save it. Finish the project. Let it initialize. More than one project is on, so let me 4 to 7 gigahertz. E field, H field, far field, and power flow monitor on. Same default frequency, project name. Yeah, now it is initializing. The first step is for modeling of a horn antenna, we have to design the guide. There are three parts here. So you first design the guide here. So waveguide, this part portion we are going to design first. And the dimension of this structure is here in this direction, we want 58 mm. This dimension we want 20 mm. And this direction we want, it means the length is 28 mm. So So it means we want 58 means minus 29 to plus 29 to keep this in the center from the coordinate, minus 29 to plus 29. Here we want minus 14 to plus 14, and in this direction minus 10 to plus 10. So total will be 20 likewise. So with this, let me go to structure. Here first make the plane, coordinate. You can see x, y, z coordinate. So when we are creating it, first step is go to view and select a working plane. View, working plane and working plane properties. Here you can mention 100 and the width is 10. So we have designed here, and now go to modeling. Here select a brick. The brick dimensions are, it is my waveguide. The waveguide dimensions are, as I said, x direction, which is our dimension in this minus 56, minus 29 to plus 29. This direction I need minus 10 to plus 10, and minus 14 to plus 14. PEC material same. If you preview this, I'm getting a, okay, this is not the dimension I want. So I think in my x direction it is rotated. Perspective view. Okay, so this is not the direction I want. This in the length is 29. So not in x direction, in z direction it will be minus 29 too. So whichever direction you are taking, please make sure the waveguide comes in a waveguide shape, minus 29 to 29. It means 58 mm here. And in the x direction, if I take length is minus 14 to 14, because the coordinates are similar in currently, yeah, this is fine. For me, it is fine. 58 is the length, here is 20, and 28 is the height. That's it. So with this, press OK. Now take another brick, and this brick we want to create at the another distance, which is the horn. So here we are writing as a 90 in the x. The plane is in this direction is x direction is 100 total. If you remember, size we have taken 100. So 90 to 92, only 2 mm thickness I am taking. Y minimum I am taking at the minus 50 to 50, and x minimum also, because square is the shape of the horn. So I'm taking the second brick as minus 50 to plus 50 again. With this review, so you can say a distance away. If I show you here, you can see a distance away, another plane created here. With this now, revolve it, select the internal pick face here and select this portion. Then rotate this and again go to pick face and click here. In between this, go to loft, and here we are not giving any smoothness here, just preview. It will select this portion. So my solid horn is selected. Now go to component and select all three components, and in the boolean here you add them. So you'll find one component. This is now, it will create a whole structure as a one component only. This is now one component. Please don't skip this step. Component should be one. So add them. Then after, select the outer shape, go to pick face, this particular face, and here turn again, pick face, turn this section, and in between this, go to the shape tool, and here you will find shell, solid or thickened sheet. In this section, you go, and here your thickness you mention as a 1 mm. Okay. So with this, you will find the structure became hollow. From one side to another side, we can check it. So actually, it is a 1 mm thickness is created. Now, keep this in the rotation of this, and waveguide side, this thick portion we want to select it. So go to pick face, select this small portion of this, double click here, and go to simulation, waveguide port, and here just click OK. Preview and OK. No need to change anything. So your waveguide port is selected, it's the same size, and now go to setup solver. Start with saving the model. There error occurred because of the meshing limit here, that you can change it by global properties. Go to hexahedral. Here you can reduce it one by one. See what I'm doing. If I'm changing it from 15 to 14 currently, and if I update, it is asking to delete first, and you can see here it is 386. It should be less than, here it should be less than 1 lakh, because that's the limit, cell limit here we have. So go down, if I go down up to 698 and I keep on reducing it, you will find still is more than 1 lakh. I can go to 7, update, still more. I can go for 15, update. Yep, it is 84,000. This will work for me. So I do this, and now I go to setup solver again. I run this project, apply, start. With this you can say, except some warnings, or most of the project will be all okay. Yes, it is running the simulation. So you can see successfully project ran, and now we can check the result here. Let's take the 2D pattern, 3D pattern. Okay, let's check the far field first at 4 gigahertz. The far field pattern here, which you can see here, it is available. You can see by rotation is the far field pattern. If I want to say in the structure how it is appearing, you go here and show structure. So you can see in the structure in this direction, the maximum radiation pattern is here 12.6 dBi. And similarly, you can go for 1D pattern, polar graph of the hand antenna. You know, is the one direction it is appearing, another one it won't be appearing. So actually it will be radiation will be in the two direction only when it goes to one to another direction. And also if you see surface current available in the structure, you can see surface current available here. You can animate the field and check the power flow, check the surface current from the structure. With this, isn't it amazing? I think you can see successfully ran our horn antenna structure. You can check other patterns as parameters and design equation. So this is how we simulate horn antenna, pyramidal horn. Thank you.